Anytime, just feel free to break in here. Hang on a second. Let me do something here. Okay. What we're going to talk about is the low bands and why you might want to operate them, and some of the challenges, and how low noise receive antennas can often help you on these bands. And we'll talk about some different ones. Some of them are pretty big and some are pretty small. So depending on how much real estate you've got available, you might find one that would work for you. And we'll start with the largest ones, and we'll move our way down to the smaller ones. What's going on here? There we go. You probably don't know me. I've been licensed a little over 50 years. My main radio interests are contesting, DXing, and designing and building equipment and antennas. I went to University of Wisconsin, where I majored in ham radio with a minor in electrical engineering. I don't know if you got anybody there in the same boat as I was. And I retired about 5 years ago from my day job. Somewhere along the line, I designed a home project for radio stuff, and the ARL found out about it and asked me to write an article in QST. And they said, well, you know, if you sold kits for this, that'd be a lot better because people like building them. And so somehow a home project got out of control, and I got a company, Unified Microsystems, which I do on a part-time basis. And I have a number of products. Right now, I'm kind of specializing on low band receive antennas and antenna switching and some other products. I'll mention a little bit about my products, but this is not a commercial. I'm kind of show you what's available, and a lot of this stuff you can build yourself. I belong to a lot of organizations here, just a few of them. And I live near Milwaukee, Wisconsin, which right now is very snowy and cold. We had about 4 inches of snow in the last couple of days, and it's probably 20 degrees. So it's a lot colder than it is normal here. So what are the low bands and why do you want to operate? Well, the low bands are generally considered 160 through 40. Some people consider 30 meters a low band. It has some of the characteristics. I kind of consider it a transition band, but it does have some of the characteristics of low bands. And one of the reasons that they're very useful to hams is because they're very reliable for short and regional communications. 40 meters is always going to be open somewhere, and the lower bands are great for regional contacts. So you see a lot of nets, traffic handling goes on around there. People have reg chews with within surrounding states, or so their schedules are usually made on the low bands. If you're a DXer at night, especially during the low part of the sunspot cycle, you can make worldwide contacts, but it's a lot more challenging to make DX contacts on the low band than it is on the higher ones. And the challenge is part of the appeal to a lot of people. Now, I'm a contester, so I want to be competitive and have above average antennas on all the contest bands. And the low bands, of course, are contest bands. And one way to do that is have better receiving capacity than your competition. And low band receive antennas can do that. So what are the challenges? Well, in a word, the challenges of low bands are noise. A lot of it's static from thunderstorms. You can have a thunderstorm 100 or 1,000 miles away. It'll just totally wipe out, the band. They'll just, be just too noisy. You just really can't hear anything. And you can also have man-made noise, QRM. Because of the short skip distances, you often hear just about every station in the band. So you can get QRM from stations that nearby. And a growing problem is noise from digital systems, like switching power supplies generate a lot of RF interference. Plasma TVs were terrible. Fortunately, that technology is kind of phasing out, and the plasmas have to be recharged, and it's expensive, and so they're just kind of getting phased out. I've had problems with cell phone chargers. My wife had one time that put me off the air until I figured out what's going on. Home power solar systems have can cause problems. One thing that the American Radio Relay League is very worried about is wireless chargers for electric vehicles. You just drive over the coil and then it generate, charge your battery. Well, you might have 10 kilowatts or more of RF energy being generated by that, and someone's going to leak out, and it's potentially a really devastating thing for us hams. So how do you hear through all this noise? Well, one way to do it is just use low noise antennas to cut down the noise. And like we mentioned, some are pretty large, but some are actually very small. And there's a lot of different ones that you can build or buy. The ARRL handbook, ON4UNDX book, the KL7AJ receive antenna book, and the internet are all good sources of information for how you can put one of these together. And there's commercial versions available too if you don't want to build your own. Well, with any sort of an engineering problem, the first thing you want to do is learn as much as you can about the system, the situation. And first of all, low band signals are actually usually pretty strong, but the noise is often louder. And the key to a communication system is a signal to noise ratio. You need your signal to be stronger than the noise. And receive antennas don't have gain per se, but they do have directivity. And if you can reduce the noise coming from other directions more than you reduce the signal, you can improve your signal to noise ratio. And that's really what it's all about. Now, some of these antennas are not very efficient. They might only be 1% efficient, and the signal might be 20 dB down from the signal on your transmit antenna. But if it cuts down the noise by 30 dB or 35 dB, that can be all you need to do to pull that signal out. Now, there's a number of different types of antennas. We'll look at a few of them here: the beverage type antennas, loop type antennas, small magnetic loops. There's some other ones with phased arrays of small verticals with high impedance amplifiers, preamps on each antenna, and then they're phased. We won't talk about those. They're pretty complex, kind of expensive. Waller flags are good, but they're very, very large. If you put one of those up, you probably need to put it up on a 120-foot tower. If I had a 120-foot tower, I'd probably prefer to have a Mantra 20-meter beam up rather than a Waller flag, but I know people that have them, and they say they're very good. The first antenna, and the one that most people think of when they think of low band receive antenna, is the Beveridge antenna. It's named after Harold Beveridge. Beveridge was an engineer working for GE around late 19 teens and 1920. And they were setting up radio telephone circuits between Europe and the United States by radio, and they wanted to be able to receive better. And so his task was to come up with some sort of an antenna that would improve the reception. And these are pretty simple. It's a long wire in the direction that you want to receive from, with a terminating resistor at one end and transform the other. And best that these things are several wavelengths long at the frequency you want to use them. And these are called wave type antennas. And here we have a simple picture of a Beveridge antenna. We have a wire that goes out maybe hundreds of feet, maybe 1,000 feet. At the far end, we have a terminating resistor to ground. At the near end, we have a transformer that converts the impedance from about 450, 500 ohms to either a 75 or 50 ohm coax. 75 ohm coax is very popular for these type of antennas. I'll explain that more later. Now, the way these things work is they're unidirectional. If we have a vertically polarized signal coming in from our favored direction, the signal will get tilted. That's because the speed of light in the soil is less than it is in free space. So the wave gets tilted, and as it moves forward, it's almost like it's dragging its feet in the soil. And this tilt will cause a voltage differential, and the current will build up along the line. And the longer the line, the bigger the current buildup is. goes to the transformer, gets converted to 75 ohms and back to the receiver, and you can receive. So signals coming from this direction will be picked up. Now, signals coming from the opposite direction will be the same sort of thing. They'll be traveling along tilted. The current will build up, the signal will build up, but now it sees a terminating resistor to ground, and so it'll be dissipated here and we won't receive any signal. So signals coming off the back end are nulled out. Signals coming in from the side, essentially you have a uniform wavefront that hits the antenna all pretty much evenly, so there's really no differential. So no signal is built up. So if you have one in direction, like they're very popular here towards Europe, you might have one over in your area towards Japan. You will put your transformer at near your where you want it to be, and you'll put your terminating resistor in the direction of your signal. You have a question?
Yeah, could you put coax on both sides and then have receive from?
We'll actually talk about that later.
Okay.
Good question. Another way to if you need different directions is if you leave this terminating resistor off, the signals coming from this way will come. Now your signal gets to the end, it's got to go someplace, and so it's reflected back, and you get bidirectional. And some people put a remote control relay here so that they can switch the other, hit to both directions. For example, if I did that here, I have a beverage towards Europe, I would want the terminating resistor in there. So I'd pick up the stations from Europe, but stations to the west of me, Arkansas or California and whatever, would get nulled out. But in the morning, if I wanted to be listening to, say, Australia or New Zealand, if I took out the terminating resistor, I'd hear signals coming that way, but I'd also hear signals coming from the northeast. But the time that we would be listening would be right around our sunrise, so it'd be already sunrise on the East Coast, and the D layer of the ionosphere would be forming, and that would be attenuating the signals. And the D layer is, if you listen to AM radio, you notice at night you can hear distant stations, but during the day you can only listen to local stations, and that's because the skywave is absorbed by the D layer at the low frequencies. But that night the D layer dissipates, and then the signals can get up to the higher F layers and be propagated long distances. But we'll talk about bidirectional beverages a little bit later. This is a pattern of a beverage engine. Does this look familiar to you? What does that look like? Have you ever looked at a pattern for a Yagi? Looks pretty similar, right? It is very similar. It's unidirectional, but there's a few differences here. Now, I modeled this with a program called EasyNet. I made the wire 500 feet long, elevated 7 feet, put a 470 ohm termination, and this is what the plot looks like at 30 degrees. And so you can see that it's pretty wide here. If we look at here, it's about 100 degrees, or the 3 dB points. And so signals coming from these angles we picked up pretty well. But you can see signals coming in from this side get attenuated. Well, actually this signal right here is about 2.5 S units down from what it would be if you had your receive antenna. So it's not a very efficient antenna. But you can see if we set the forward direction at 0 dB for a reference, coming in here it's 30 dB down. That's a huge cut in the signal. If it's coming from the back, it's not nearly as much. We have about almost 20 dB, which is still pretty significant. So we can really null out signals from the directions. Now, these are broadband antennas, and they can be used on over a wide range. The same antenna at 80 meters is going to have, it's only about a little under 7 dB down from a transmit antenna. So its signals are going to be louder because it's longer in wavelengths. And also the beam width will be narrowed down. So our pattern would probably look, kind of more like this, on the same scale. And if I use it on 40, we see now we're only less than 3 dB, which is like less than a half an S unit down from receive antenna. And it's quite a bit narrower, a lot more sharper. And you see the front to back doesn't change too much. Now, that's a little deceptive because if we start getting up around 40 meters, this kind of too low back pattern is going to be broken up into some smaller spikes. So depending on the exact direction, you might get, you know, even more attenuation or a little bit less, but you'll still get quite a bit of attenuation off the back. Now, some notes: you put up a beverage, longer is better, but at a certain point, it doesn't really help you anymore. You know, 800 to 1200 feet, you know, is considered pretty good. There's not a whole lot of point going more than 1200 feet. I've got a pretty good chunk of land here, but because of the shape of it, the best I can do and the interesting directions is about 350 feet. And that's still quite effective. It's a very effective antenna, even on 160. Now, the real world comes into effect. Your ground's not flat. Just basically try to follow the pattern of the terrain. Keep it a constant, whatever you have. 7 feet's kind of a common height. That way people don't run into it. Deer are a real problem here. They'll snag it and take it down. If you have a tree in the way or something, you can do a little jog around it, but just get back on your same direction and you'll be okay. You want to stay away from close medical objects because they can inject noise into your system. So you want to try to do that. These actually work better in poor soil than they do on highly conductive soil. I had a customer who was having problems with his, and turned out he had it in an area in Florida that at high tide, the seawater would go over the land, and so it's actually over seawater, and it didn't work very well. So poor soil is actually better. Now, you know, these are just general rules. Beverages just want to work. They just want to work, even if you aren't doing things perfectly. So do just the best you can. W8 GNM, Jeff is a really sharp guy on this stuff. And he gave a talk in the August 2021 QSO Today conference, and you should be able to find that on YouTube. And he talked about things like sloping and zigzags to increase electrical length. So there's a lot of little games you can play too, which are kind of interesting with the beverage, but they just want to work. Now, I do sell some components for making beverages. I have a beverage transformer and a terminating resistor that you can buy. These are very simple to build. If you go online, you can find the directions and make your own. They're pretty inexpensive. Mine are in NEMA rated cases, so they can handle the weather. And I use stainless steel hardware, and I also give them a coating of conformal electrical coating for in case there gets any moisture, and it'll prevent any oxidation and stuff. And I put a gas discharge tube, and we'll talk a little bit about that if you want to build your own low band receiver, why you want to probably put a gas discharge tube in there. Now, the beverages we talked about here were elevated beverages. And again, these are usually up, 7-8 feet. They're actually most effective probably around 4 or 5 feet, but then, people are going to run into them and animals will run into them. But you can also put them on the ground, and they're called beverage on ground or bog. And if you do that, just lay it on the ground. You don't want to bury it. And if you can actually raise it up a few inches, I know people that had like stone fences and stuff, and I just mounted off the fence a few inches will help a lot. Now, one of the advantages of the beverage on the ground is, remember we talked about the velocity factor of the electromagnetic wave through the soil versus free space. That actually makes it electrically longer than its physical length. So 90 to 200 feet are kind of good lengths. I know one guy was one I consider one of the best ham radio station engineers in the country. He thinks 225 feet for a bog is the optimal length for 160 meters. So if you don't have the space to put an elevated one, putting a beverage on ground might give you some of the same effects of having effectively a longer one. A few things now. It's not up in the air, so it could be a trip hazard, and you don't require supports. Because it's close to the ground, the impedance is lower, so you want to use about a 270 ohm resistor for termination as opposed to a 470. But nothing is free in engineering stuff, so the signals are going to be much lower on a bog than they will be on an elevated beverage, maybe 10 to 15 dB. So you probably are going to need a preamp if you do put a bog in there. We'll talk about preamps a little bit later. Some other type of antennas that are very popular are loop antennas. The K9AY is a very popular antenna. We'll talk a lot about that. Flags, pennants, U or EWE, and V3VO are different combinations. Now, before I said the beverage was a wave type antenna, and how I showed how the signal built up as the wave travels along the wire. These act more like phase verticals rather than a wave antenna. So they work on a different principle. Now, the K9AY array was developed by Gary Breed, K9AY, and it was described in the September 1997 QST. Gary's a friend of mine. He lives about 100 miles from me, a really sharp RF engineer. It's basically two diamond-shaped loops at right angles, and the system you can switch in 4 directions instantly. And the nice thing, it doesn't take very much space. You've got about a 20-foot by 25-foot space, and you've got some sort of support around 25 feet, a pole or a branch or something. You can put one of these things in there, and it's a very good low band antenna. Now, this is kind of a diagram of one of the loops. You have this diamond shape, you have a ground rod, you have a transformer, and you have a terminating resistor. And you can actually use the same kind of transformers and terminating resistors that you use in a beverage here. These are normally mounted right close here to the ground rod. Now, in this case, remember we said if we're at a beverage and we're at the transformer, we were looking at the terminating resistor, we'd be looking at the direction that we want to be receiving signals from. Well, this is kind of backwards. If we're looking in that way, we're looking in the null direction. So if we want to see the direction the signals, a favored direction, we'd be looking from the terminator to the transformer. Now, these are close to the ground rod. And if we put some relays in here and we're a little bit clever, we can switch and move the transformer to one side and move the terminating resistor to the other side and reverse the direction. And if we make another one of these at right angles and put another relay, now we can switch it in 4 directions. So it's very nice. And these are pretty broad, so you pretty much cover all directions with just the two loops. Here's a picture of the one I have at my station. I've got a pole made from PVC pipe with there's some wood reinforcing at the joints. It's about 24 feet. You can kind of see the wires through here. This one goes to the northwest this direction, the southwest this direction. We're looking to the southeast, and coming back this way is northwest. You can see the control box right here. And I've never really felt the need to have a preamp with this. I feed it with RG6 coax, which is the stuff they use for wiring up cable TV. And we'll talk some more about coax for these systems a little bit later. Here's a picture. This is actually an old picture. This is an older version of the transformer and switching. And this is actually a picture of the one that's in there right now. We have a transformer on a ferrite core. We have our relays here for switching directions. This is the gas discharge tube, and we'll talk more about that in the next slide. And then I have the connections for the control cables for switching, turning the different relays on, and for the terminating resistor, and then for hooking up the ends of the wire of the loop. Now, this part here is an experiment I did. Was I put in some extra relays and a bunch of resistors, and I could switch them in and get different terminating resistances. And the idea was to improve, the performance under different conditions. And I did find some advantages on certain situations. It seemed like the different resistances would change the angle of the null off the back. So if I had a signal coming in directly from the back, I could adjust that and I could actually get quite a bit of difference in nulling that signal out. It never made any difference on the signal strength of the received signal. And it was useful, but the number of times it was useful was so limited that I don't have that running right now. I need to do some other stuff, and so I just don't use that. But it is an interesting thing if you decide to build one, you want to play around with it. Now here's a schematic of mine. If you want to look at this later, you can go to my personal website, W9XT, and I've got some more information there on this. But we have a transformer. Now this is different from Gary Breed's first design. You see it's a split transformer. You saw the toroid type of, the binocular type of core that I use. 2 turns on one and 5 turns on the other. The original design used a single coil with a tap off of it to get the proper impedance match. However, since then people have built this and found that using the isolated windings is much better from a noise standpoint. It cuts down other noise that's picked up, something we'll talk about a little bit later. You can see the gas discharge tube I put over here. The original design didn't have that. Now I had problems with my beverages and K9A wire array. I don't do a lot of low band work during the summer, and if I forgot to unhook the wires, sometimes in the fall I would hook them, get on, and it'd be dead. I couldn't hear anything. And I would go and open it up, the boxes these things were in, and I saw nothing looked bad. Replace the transformer, it works fine. Now my assumption is that some sort of a nearby lightning strike in the summer caused some current surges, which caused the characteristics of the ferrite to change and not work very well. Since I started putting the gas discharge tubes in there, I have not had a failure. I have probably between 800 and 1,000 different units in the field that I've sold that have these in there. I have not heard of a single failure like that since then. These things are pretty inexpensive. You want to look for one that's low voltage, usually around 70 volts or 90 volts is small, but they're under $1, so it's cheap insurance if you ever want to build any low band receiver to put it across your transformer, and it might provide some additional protection for your receiver. Down here is the control lines for the receiver, the relays to switch the thing around. And no voltage in both relays will be open. I put voltage on one and they'll have one, put voltage on the other relay. If I put voltage on both of them, and you can see the different setup I got. No voltage is northeast, relay A is 12 volts to southeast, 12 volts on relay B is southwest, and 12 volts on both is northwest. Now the original design used a bias T, and he put a voltage on the coax back to here, and he had some steering diodes. So if you had positive voltage, it would turn on one relay. If you put negative 12 volts, it would turn on the other relay. And if you put AC on, it would turn them both on. Now, my experience with doing that is if you aren't very careful, you'll inject a lot of noise, and it just generated a lot of noise and really reduced the effectiveness of the system. And I've tried it with remote switches for beverages and that sort of thing. So I kind of come to the conclusion you're better off using separate control lines and just keep the power to control these things off the coax. Now, obviously, some people do it, and some of the commercial units do that, but my personal preference is just not to try that. What's going on here? Okay, another type of antennas are smaller loops. Flag antenna and the pennant antenna are two commonly ones. They're smaller. These two types are generally put at least the bottom part 8 feet off the ground. Terminating resistance is 1,000 ohms on both of them. And they can be useful if you're interested in one particular direction and maybe you have some trees or flagpoles or something that you can use to support them. They're pretty stealthy, you can't see them too well. A couple of variations are the EWE or U and the V3DO. The U antenna got its name because it was invented by a Scottish ham who raised sheep, and it looks like an inverted U. And so he just did a play on words with the U for the term for a female sheep. But these are pretty small. It's like only 15 feet high and 40 feet. It looks like a beverage, but it's kind of smaller, but also higher. And the U antenna, you use the ground to kind of complete the loop. The V3DO version basically brings the wires in closer together and uses the wires a foot or so off the ground as to complete the loop. And if you build this one, you can get by with just use the same ground rod for both. And he has different sizes depending on whether you want to optimize it for 80 meters or 160 meters. And again, 1,000 ohms. Now, the very small ones are small magnetic loops. These are typically 3 or 4 feet in diameter. They're available commercially. You can find how to make your own yourself. Because they're small, you can rotate them. Now, because they're small, also, you're going to probably require a preamp. You're not going to get a lot of signal off them. Another disadvantage is they're bidirectional. If you look in the thing from the top, the nulls are going to be off, in the right angles, the plane of the wire, and the signals will be, and the plane of the wire will be from this direction or this direction. So if you're trying to listen to somebody in one direction and you've got a noise source at 180 degrees, these aren't going to be very useful. But a lot of times they're used by hams when they have a single noise source. They have a neighbor with some particularly noisy device, and you can use that to null them out. And again, there are homebrew and commercial designs. I've given this talk a number of times, and one of the times I talked to a group in Arizona, and there was a guy present there. He made one himself that was about 6 feet in diameter. He was very, very happy with its performance. So if you make them a little bit bigger, if you're making your own, you're probably to the advantage. Now, somebody asked about switchable bidirectional beverages. There's actually a couple of ways of doing that. There's one that uses essentially 2 wires instead of 1 wire for the beverage. And you have one of the wires is terminated at the far end and the other one is not. And you have some complex transformers and switching systems to do that. And you can build these, and again, there's commercial versions. Now, there's another version was by Jeff W8G&M, the guy I mentioned before. He designed called the BevFlex, and this uses coax for the antenna elements, but it's also uses a part of the feed system, and it can be fed at both ends, or it can be switchable in different directions, and you can feed it at any point. And you can also make a flag or a EWE or a V3DO. Now, he came to me a few years ago and asked me to manufacture and sell these things for him, which I do. And I redesigned some of the packaging. My engineering experience has been in manufacturing, so I took some cost out and made it more reliable. And I'm not trying to sell you guys this, but I think you might find it interesting how it works. It's a very clever design. I wish I had thought of it. There's 4 parts. There's 2 terminating units. There's a feed unit and a control unit. And you start out, if you're doing a beverage or a bog, you can do either. You, instead of using a wire, use RG6 coax. Now, RG6 coax is the stuff, again, that they use for cable TV. And the stuff's pretty inexpensive because they make so much of it. And it's very low loss because it's supposed to be doing TV signals up to 1 gigahertz or more. And you're down here at the low megahertz range. So the way this works is the outer shield of the coax acts as the antenna and the wire. And so the signal propagates down and it gets tilted like before. The signal builds up on the coax. It gets to the end, instead of the transformer back to the shack or a terminating resistor, there's some transformers in here that take the signal at that higher impedance, 450, 450 ohms, and transform it to 75 ohms, and they inject it on the inside of the coax. So the antenna part is in the outside, but the in part of it's part of the feed system. So the signal that's coming from this direction gets injected back in the coax. It gets to the feed unit that splits it off and sends it back to the shack. Because it's symmetrical, the same sort of thing happens. The signal propagates through here, gets to the terminating device, gets transformed to 75 ohms and injected in the coax, and goes back to the shack. And we have a switch here which you can select each one. It also terminates the unused one, so we don't have the reflections going back and messing up our pattern. And it has some different tabs on the terminating here, the terminating units. So you'll get the right impedance if you're making a beverage, or if you make a bog, you put your ground rod off the other one. Very clever design. I said, I wish I had thought about that. But it can also be used in making bidirectional loop antennas like the EWE and the V3DO. If you're interested in playing around with a lot of different type of antennas, experimenting, that could be an interesting thing. And they also make a version that can go in 4 directions too, which is essentially 2 of them with a switch. Now, some other considerations if you decide to build or buy a receive antenna, and one of them is receive protection. If you have a receiver that has a separate receive antenna port, and you're transmitting, especially with high power with an antenna nearby, you can put enough energy into your receiver to burn out the front end of that second receiver. And so you want to use some sort of a protection. We'll talk about that. Interaction with other metal objects, we can pick up noise that way. We'll talk about feeding the antennas, preamps, and common mode currents. So as I said, if your transmitter can couple a lot of energy in, if you can't keep them separated enough and you're running high power. So you'll probably want to consider getting a protection device. First of all, try to keep them as far apart as possible. It's a good start. But there's different protection devices available. One is just essentially a relay that disconnects the receive antenna when you're transmitting, so you don't get that connection. There are versions out there that are RF limiters. They will essentially prevent they'll let the low signal come through, but prevent high ones, like back-to-back diodes and some other things. The BevFlex has some of that built into it for some protection. So that's a couple of things you can do. And of course, you always want, like any other antenna, you want to disconnect it if there's a possibility of an electrical storm. Mentioning you want to keep the receive antennas away from other metal objects, because they can couple noise, especially vertical conductors. If you're really serious, you might consider detuning other transmit antennas when you're receiving. I was at a talk a couple of years ago, which was very interesting. It was the guy was a consulting broadcast engineer for AM stations, and AM stations have to have a certain pattern because so that they might change that during the day. If you're like on the coast, you don't want your power going out in the ocean. That just wasted energy. You're not getting any listeners that way. But also sometimes the FCC were required to be beaming in different directions to avoid interference. It's a skip leg things out, so it won't interfere with another station on the same frequency. And every year or so they have to go and check the pattern. He was out there, I think in New Jersey, doing that, and he found that their pattern was out of compliance. And they tracked it down to a cell phone tower about 2 miles away, which was acting as a re-radiator and changing the pattern of their signal. So they actually had to go through and detune the tower. It was quite interesting. But anyway, these are things to consider, but do the best you can and don't let the perfect be the enemy of the good. Feeding receive antennas, I like 75 ohm coax. Some people use 50 ohm. This stuff is pretty inexpensive compared to the coax we use. It's very low loss. And so you can get the stuff that's self-flooding, the seal flooding. So if you have some road cut the the insulation, it'll kind of reseal itself. It's a little hard to find. There's two versions. There's a dual and quad shield version. The older stuff is probably dual. Now, the cable companies had a problem meeting FCC leakage specs with their signals. So they went to a quad shield, which is about 15 dB more effective shielding. The shield on the RG6 has a metallized mylar, and then on the outer side, there's a metal braid. And then the quad shield puts another mylar layer over, and then another braided shield around that. If you have to go out and buy some RG6, I would buy the quad. It's not that much more expensive. It'll be a little better. But the important thing to remember is you want to use the same connectors, the right connectors. If you mix the type of connector into coax, you're not going to get a very good connection. It's going to be a real mess. So make sure those are matching. And they do make them out there that have gaskets that are designed for outdoors, which if you can find those, it's not a bad thing to do, but you're always going to want to waterproof your connections regardless. I'm often asked, do you need a preamp? Generally not. If you have an older radio, especially an older tube receiver, it may not have the gain you need. If you have a small loop or a short beverage on ground with a small signal, you probably will need a preamp. If you have a really long coax, maybe you'll need it. Now, some radios have preamps built and it can be switched in and out. I have an FTDX 5000 and they have a separate preamp, but it's only really designed to be used on 6 and 10 meters where the band is very quiet. If you use it on a lower band, you're probably going to be overloading your signal and cause all sorts of receive distortion. So you would never want to use that normally, but I found in a few cases when I've needed the preamp and I have a receive antenna, it worked, so I didn't have to buy one. Now, if you do buy a preamp, there's a few things to look for. There's 3 characteristics: gain, noise figure, and the dynamic range. The one they're going to probably tout is gain, because gain is real easy to manufacture, but you don't really need it, but it sounds impressive. You know, our preamp's 30 dB. You probably only need 10, maybe 15 dB. If you can get one that's variable gain, that'd be even great. They may talk about noise figure. That's really not important in this application. On VHF and UHF, they often use low noise preamps, like especially if you're doing things like moon bounce EME. And the reason they do that is the background noise, the cosmic noise, the atmospheric noise is very low. And the noise generated by the front end of the receiver might be more than the noise that's being received. So if you amplify the signal, you're increasing the noise and your signal noise ratio gets worse. But if you put a very low noise preamp in the front end, then you overdrive the noise generated by the first stage of the receiver and you're able to receive weaker signals without that problem. But on the low frequency, we might have S9 noise from atmospheric noise. And if you're the front end of the receiver is generating S9 noise, you've got a lot more problems than that. So you got a real problem. The real one that you're interested in is dynamic range. And that's pretty much like how strong and how weak a signal is going to get without clipping or overloading. Unfortunately, the preamp specs very rarely mention that, because you could have a loud signal from a nearby ham that would cause all sorts of overloading and you won't be able to hear the weak signal you're trying to get. And if you live near a broadcast station, you might need to have an AM broadcast filter to notch that out. Another thing is common mode noise. Normally in a transmission line, you have a current going on the interconductor and an equal and opposite current on the inside. And because these are so close together, the fields cancel out and you won't radiate, you won't pick stuff up. And of course if it's coax, you got shielding. But if you get some situations where you can get common mode noise and you have actually a signal traveling on the inside and the outside of the coax, and that can generate a lot of noise. Some ways of getting around that are burying the feed line on the way back to the shack. That seems to help. Putting chokes or ferrite beads on the coax as it enters the house or gets near to the receiver is good. one-to-one isolation transformers can cut it out. And again, I mentioned I don't like the bias tees because I think that can sometimes, if things aren't done properly, you can get common mode noise that will come and give you problems. So in conclusion, low band receive antennas can be a real help on the low bands. Have realistic expectations. They're not going to bring a really weak signal, to S9, but they might bring it up enough that you can hear it through the noise. There's a lot of different designs, different characteristics, and there might be some that will fit in the space you have available. Commercial available. I encourage you guys to homebrew some if you can. It can be very inexpensive and you can learn a lot. And if you put one up, just do the best you can. You're never going to get anything perfect, but it can be a big improvement. And if you can have multiple antennas. You'll find that on some nights one antenna will work better than others. Real quick look at my station, how I have it. I have a tower here which has got a tri-bander and some dipoles for 40 and 80. That's 50 foot. There's a tower over here, it's 60 foot. It's got a 40-meter beam and a small tri-bander, but it's shunt fed for 80 meters. There's a bunch of radials going out. It's also support for 160-meter inverted L, which goes up with some trees and then comes over the tower. Over here is a 30-meter vertical. But for receive, I have a Beverage to the northeast, which I was planning on switching over to BevFlex this week, but we got a real cold snap and a lot of snow, and my motivation to do that right now is kind of low. I've got another bog, which is the northeast and southeast, and I've got a BevFlex short bog, which is northeast and southwest, which I basically put up to compare how it compared to the Beverage. And then my K9A wire arrays down here. And I have some 4-way switches. These are ones that I build and sell, so I can get a good price for them. I have one down here to switch this stuff, and I have another one in the house to take all the various coaxes. And I built a control box. You can see I have 4 directions. And as I switch the direction, it'll switch the K9A array, K9AY array to the right to one direction. But at the same time, it'll switch this. Now I don't have southwest until I get the BevFlex in here, but then I'll have 4 directions. And so a lot of times if I'm calling CQ, I'll call CQ and listen to the K9AY array, and maybe I'm focused on the East Coast or something. But if I get a call off the side from, say, from Florida or off the back or something, then I'll usually hear them on the K9Y array. I may not be able to copy them, but at least you'll know they're there. And I can just rotate the switches around to the different direction to peak them. And usually that's enough. But if it's not, then I can flip over to the Beverage and I'll already be pointing in the right direction. And that almost always brings enough that I can copy it. If I were to call CQ and listen on the Beverages, there'd be a lot of times guys would call me and I wouldn't be able to hear me. So that's why I like the K9AY. K9AY is I find really useful for more domestic, and I use the Beverages more for DX. So that's it. I've got a personal website, w9xt.com, which you can find some information about my station. I've got some other stuff on electronics. Do any of you guys do embedded designs with microcontrollers for projects controlling things? Yeah, I've got a series of things of interfacing different devices to microcontrollers. You might find that interesting, and how to connect up to your microcontroller to things. And my business is Unified Micro for some of my products, if you're interested in looking on that. So do we have any questions?
This is Dennis Derrickson. I'm a professor here at Cal Poly. I wanted to thank you for that interesting one. I'm also Ham, who's grew up in Minnesota, so just made it out here to California, and so very informative talk. And I'll have to do something about 160 meters soon.
Well, that's great. I'm encouraged to see your students are interested in ham radio. They were a huge benefit to me both while I was in college and in my career. In a lot of the classes, we were mostly math and theory, but I was one of the few students in the class who understood, hey, well, this is what this stuff's used for. So it's a lot better, understanding, and things I learned in ham radio, I used in my engineering career, because just, things like RF stuff and transmission lines, and, digital stuff uses our transmission lines because of the speed, and just knowledge of that. And I've got involved in EMI testing with the FCC because of my ham experience. So it's really valuable, and I really encourage you all to learn all you can on ham radio and the practical aspects, as well as your schoolwork.
I do have a question. I missed the first part of your talk. I didn't get there the first 20 minutes. You're talking about beverage antennas. One thing that was I didn't see, and probably it's obvious, but you do these beverage antennas, and then you get a wave going on the wire, and then you terminate it. Aren't you just throwing all your power into the resistor then?
Let me go back to the slide. What happens is the signal coming from this direction is going to vertically polarize. It's going to be propagating along this way, and because the velocity factor, the part near the ground will be slower, and the signal actually gets slanted. And as that moves along, it'll build up the signal, and then it'll go through the transformer into the coax. But signals go in the other direction, like you say, it'll build up, but there it'll go to the terminating resistor, and we get rid of that signal. We don't hear it. And the idea is you only want to hear the signal in the direction of that you're interested in, that one direction. You don't want to hear the signals, the interference coming off the back.
Okay, so I guess you actually don't want to have this too high off the ground then. You just want to have a wave that's interacting with the ground, and a wave that's at full speed, and then okay, but this is just receiving antenna only then? You would not use this?
This is only a receive antenna. Now the optimal height is probably around 4 to 5 feet, but then that's a real problem because it's a tripping hazard for people, animals around here. We're out in the country. Deer are a real problem. So most people put them up higher, and so they lose some effectiveness at higher. But you can also put it on the ground, which has some advantages. But the signal is quite a bit more attenuated, and if you raise it up, you'll get more signal. My kind of general experience is the higher it is, the bigger the signal, but the lower it is, the more directive and effective it is for cutting out the noise. And 7 feet is kind of like 7 to 8 feet is pretty much the compromise between the mechanics and the electrical characteristics.
Is this going to perform a lot better than a inverted V general purpose, just like you do in 80 meters, or is it about this?
Yeah, it'll be quieter. It'll be quieter because it's it's going to be more directional. I mean, the inverted V is going to be pretty much omnidirectional. So if you're trying to talk to somebody to the east, and you got noise, some noise coming from the north to the south, you'll pick that up too. And but with the beverage, it'll null that noise out, so it'll be easier to copy the signal that you're trying to listen to.
Is this noise mostly like lightning noise that you typically have from storms?
Static is a big one, but it can be interference from other stations as well.
Thank you. Really, really interesting.
Yeah, so could you put another transformer on the other side and feed it with a separate coax to essentially like compare and do HFD direction finding?
You could probably do that. You'd require some extra switching. I would say, if before I would do that, I would probably go online and look for some articles online for bidirectional beverages, and there's probably, you might be able to find them in the antenna handbook or the low band. It'll be a little bit simpler to construct it that way, rather than putting the transformers and switching at the end. You can certainly do it, but I think the way they do the normal bidirectional is probably a little bit simpler to implement.
All right, I was thinking for something essentially like watts and watt direction finding, but with a beverage instead of a loop. Where you
well, one of the problems is
compare signal strength.
One of the things with beverages is that they're pretty broadband, and if you remember the pattern here, if you have a 500-foot one, you know, the 3 dB points are like 100 degrees. So that's pretty wide. And if you're trying to do directional finding and you say, yeah, well, it's somewhere in this, you know, 100 degrees or plus or minus 50 degrees, you're going to, you know, you're not going to be very precise. You know, rotatable loop or something like that would probably be more effective for direction finding. Unless you have, you know, a lot of beverages. I mean, there's some stations that have, you know, like, you know, half a dozen different beverages in different directions. If they're generally contesters and they'll have a beverage to Europe and a beverage to Japan and a beverage to New Zealand and maybe one to Southern Africa and, you know, another one to South America. So, you know, then they can do some, but they're pretty broad and it's probably not the best way to go about direction finding.
I guess I had a quick question behind the camera.
Yes.
So I guess why are they so low to the ground? What makes them, I guess, better for that? Because I'm just so used to inverted V's or configurations like lambda for 2 over the ground, something like that.
Yeah, it's a little not intuitive, and it has to do with the signal, you know, and the interaction with the ground. I'm not a super expert on the exact theory of what's going on down there, but that's the thing. But there's a lot of things. I have another talk that's been very popular where I talk about antenna takeoff angles and how the ground has a lot of effect on that, which is quite surprising how local ground effects can affect that. So depending on who you want to talk to, you may want your antenna up higher or you may want the antenna up lower. If you have like in a dipole, if you're interested in talking to stations that are, you know, a few hundred miles away, you actually probably want it low. If you want to talk across the country, you're going to want it higher because of the takeoff angles of the signals.
Okay, cool, thanks. More questions from people? All right,
I think we should try putting one of these up down via Carta.
over summer break or winter break.
We'll do beverage on ground on the sidewalk, a couple inches above all the way down via Carta.
Yeah, that'd be.
I'm sure they'd love it.
You would approve.
I hope you try some of this stuff out. You know, you learn a lot playing with this stuff.
Or we could do it out in Holy Canyon.
Yeah, no, it'd be really cool. They do some, the lower band stuff, because like we're always on 40 and 20 and 10. We're never really, dealing with 80, even though we have the 80 meter for the both beside the whisper stuff that you got.
Yeah, Whisper. I think Whisper FT8 stuff we do in low band.
We do have our building here for Lexington Engineering Department is a single-story building that's 300 feet long. So if we just put a long wire above the building or
I wanted to. I was
calling
talking
the eaves or something like that, we could.
They're really interested in some really low band stuff. You might look into 630 meters. If you go to my website, I designed and built a little Whisper beacon transmitter for 630 meter, and I have a small inverted L with a big loading coil on it, and the transmitter puts out about 12 watts, and I figure the antenna is about 1% efficient, so I'm getting like 100 milliwatts affected radiated power, but it's been picked up as far away as Hawaii from Wisconsin. That's pretty amazing stuff.
Yeah, Whisper is amazing.
Yeah, it really is. And
we were picked up in Antarctica on like 500 milliwatts or something, I mean, maybe even 100 milliwatts on like 80 meters.
Yeah, it's amazing. My 2 meter moonbound stuff is down right now, but I've made contacts off the moon with almost 30 dB below the noise level. And the path loss to the moon and back on 2 meters is 250 dB. Think about how much that is. That is an awful lot of loss. It's an incredibly mind-boggling amount, of loss.
We need to get our EME station going.
That would be cool.
We have
It's pretty cool. Mine's down. I hope to put it back up again.
yeah, we We have a radio for it, but no antenna, or well. Maybe our antenna would be usable, but no receive capabilities. We don't have LNAs or anything for 2 meters.
Well, there's something I found very interesting. You guys might want to check this out. There's been some people that have been using these LMB down converters. You can get them on Amazon or eBay for like $30 and using these little SDR dongles, you know, like $25 dongles, and using a small satellite receive only dish have been actually able to pick off EME beacons at 10 gigahertz. There's just a lot of work on the high frequency, people doing some really interesting stuff going up there. I want to play with it when I get time. The thing about ham radio is there are just so many neat things. I've been a ham, like I said, over 50 years, and I'm probably into as many things at one time or another as anybody. And I just still feel I've scratched the surface. There's just new stuff coming out all the time.
Yeah, that would be cool to try. That would be
And it's not expensive, you know, you can
Yeah,
scrounge up, you know,
yeah,
you probably
with
have guys with SDRs already and maybe scrounge up in a small satellite dish out of the trash. I mean, we're talking not the, you know, a bigger one would be nice, but I mean, just a small, you know, small 3 or 4 foot ones.
Yeah, we have those dishes laying around all over and have been wanting to play with them. And SDRs with all the microelectronics, all that stuff, mini circuits, you could probably design a LNB for not terribly expensive, or yeah, just buy one.
Yeah, you know, buy one and then design your own and see if you can do it better, you know.
That never works out well. I'll learn that the hard way.
But you learn a lot. You always learn a lot. Whenever, even failures, you learn a lot.
Yeah.
Hey, Gary, are you sharing your email at all?
My email is, yeah, well, the easiest one is, well, hang on. Just put W9XT@Unified Micro is my email.
All right, well, perfect. Thanks so much for your presentation. That was great. Yeah.
Well, I'm glad to do it, and good luck to all you guys.
Yeah.
Thank you.
Good night.